Oh, oh, I was going to start at 2 minutes after the hour, but okay, we can start then. Okay, hi everybody. Good morning, afternoon, evening to all of you who've joined. I'll give a tiny bit of background, but I'll let when we take it from there. I'm a system software architect to work for Mobileye, and designing features for safety critical systems, in particular automotive systems. Wenhui will introduce herself. The work we have here is, and I see there's quite a few new people, so I will give, you can go on to the agenda to the next one, okay? It grew out of work which originated together with Shua, who's not a presenter here, but who did a lot of work together with me, trying to classify, categorize, identify different kernel configurations. The original work stemmed from work that had been done on CWEs for security, and it has branched off into a foundation, let's call it, of a database of kernel configurations for safety. I'll give a little bit of background of what we have done and why we have done it. But the work to date, if you go to the database itself, is very much focused on embedded systems, because that's pretty much where my experience comes from. And as we're preparing that document for publication and opening to the public, perhaps so that it should grow and others can benefit from it, we realized that we haven't focused on those applications which are cloud-based and what type of features are more relevant in that kind of environment. So the work session today is going to open up the database to discussion on new features which may be more relevant for cloud-based systems. Okay, can you go to the next slide? Okay, for those who are not familiar, the justification for this work really comes from compliance with safety standards, most specifically the domain from the automotive domain, ISO 26262, which defines a concept called freedom from interference, which I would imagine most of the people on this call are familiar with. For those who aren't, it basically defines some kind of a feature of software or hardware, some kind of system, safety critical system, where we have some way of validating that two or more elements won't interfere with each other in such a way by failure that would lead to a violation of a safety requirement, meaning that each individually perhaps can be without failure, but because of the interaction, that may lead to the violation of a safety requirement. Okay, and it focuses on different areas. What we have done in our work is focus on aspects related to memory, and there's some examples quoted from the safety standards. I won't go into all those details here, it's out of scope, and also issues related to different types of failures which are related to timing and execution, things such as deadlock or race conditions and other such matters. So the point of our database was to identify different kernel features, what are normally really, .configs, which can be enabled or disabled, and have a potential by either enabling or disabling those features, they may be helpful to support safety argumentation related to freedom from interference. Okay, next slide. Okay, and in our database, there was a link somewhere. I think it fell in the whatever. But we'll see, maybe soon we'll open it up. But anyway, we related to, as I said before, memory protection and timing execution first as fundamental safety issues. Currently, the configurations which are mentioned in the database are focused on embedded systems. For memory, for example, we deal with different types of memory: user, stack, user, heap memory, kernel memory, whatever, kernel stack, kernel heap, and certain practical considerations to help people. We'll open it up later, sure, it's okay. In just a minute. This is just what we dealt with: architecture considerations and oh, it is the link there. Huh. It just doesn't show with an underscore. Okay, so that'll be easier. Thank you. Okay. Okay, you can get rid of just okay, okay. So if you could go into the current database, it deals with different areas and relates it to the different system attributes. And for example, maybe go down to stack protector. I think that's an easy one if we don't want to wait, spend a lot of time on this, just as an idea, because I think that's a very well-known and common stack protector. Where is it? Here, stack protector, okay? So stack protector is a pretty standard kernel. Oops, you jump back. Wenhui, where? Go down, 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 down. More. Here we are, line 17. Okay, stack protector obviously it's a kernel, a very, very standard kernel configuration, which sets up canaries, guard areas around the stack memory, and causes a kernel panic if there's for some reason a stack overflow, which overflows into the stack, into the canary area. And it's a standard stack protection system, which is inherited from security. And we claim here that it may be relevant for safety critical systems as well, if there is a need to protect the stack, which is a pretty standard type of safety requirement. Okay, what we added here, if you go when we a little bit to the right, are some practical considerations about the you need some cooperation or collaboration with the compiler. It's enabled in you know, whatever, if there's performance issues, et cetera. So we brought all that data and information so that it's helpful for system integrators who want to be able to use this information. Okay, so this is what we currently have. And what we're starting to work on now, and again, I invite people, we'll send the link afterwards. People, you're invited to add to this database. If you go again all the way to the left, it's currently focused only on memory protection and, oh, okay, you have the link here in the chat, thank you. It's only focused on memory management issues and timing and execution, as I said before. Okay, what we would like to focus on today is the extension of and the relevance of these features to cloud-based systems, if they're relevant for guest or host operating systems, and specific considerations in that type of environment. Okay, so Wenhui, I'll let you take it from here. And we'll open it up then to discussion.
Oh, yeah, So for cloud providers, we know, in the cloud, supporters like architecture differs. There are some special security configurations and safety configurations about different architectures. And also the cloud providers might provide different instance types. For example, if you want to provide the STX or TDX instance types, some of the cloud providers provide them with bare metal instances. And for some of the memory enhanced instances, such as PMAM instances, the cloud providers provide both bare metal instances for PMAM and also VM instances for PMAM. And for the PMAM instances, they have the type 1 VMs and also the type 2 VMs that they are supported by the different cloud providers. For example, Amazon provides both type 1 and type 2 VMs. And also some of the cloud providers also provide the cloud native, such as the Kubernetes containers support in VMs, such as the Kata containers. And some of them provides the cloud native container instances on top of bare metal versions. Also, the cloud providers have other instance types, such as they support the platform as a service. They also support a function as a service. So what we will wonder here is for different instance types, is it possible for us to give different configurations for these instance types, and what are the security requirements? Because we have provided different interfaces for the customers, which means the attack interfaces are different. So if the attack interfaces are different, then our security model are different from case to case. So if our security model are different from case to case, that means our safety requirements and specifications and security requirements and specifications will be different from the between the different instance types. And also except for the safety configurations and requirements, we have taken into the security configurations. The security configurations is mainly used for enforcing the information flow integrity on the shared resources. Not only for this security, for the information integrity enforcement, but also for some security bugs, the branch prediction related issues, the recent patches, they are different from they are different based on the different security requirements. So for example, even for the information flow integrity in the shared resources, the issue is different. For example, some of the systems, they are supporting functions are mainly supporting the inodes or the entry of files accesses. They probably require a different security models, such as C, Linux, AppArmor, SMAC, and Tamayo and Yama. And even for the integrity insurance of the different security modules, we have the EVM, IMA, and all combined system to enhance the security of the extended attributes. Our practical considerations here for the security selection is what are the shared resources to be protected in this specific security model security model under this instance type, based according to the different attack interfaces, and also what are the runtime impact it brings when we use or select one of the major security modules, or like when we select one of the integrity protection for the extended attributes. So let's go.
Just one point I want to make here. One of the focal points for this working session is similar to how we started our work for the embedded system, the configurations. We grew from work that had previously been done for security. The intent is to do the same here, okay? We are building on work that has already been done and different frameworks and that exist for security. And the major question here is, what is relevant from there for safety? And how do we develop a similar type of infrastructure for safety, for satisfying safety requirements?
Yeah. So we categorize all the security related configurations into 3 parts. One of them, the first category is focusing on the speculation attacks. There are 5 configurations specifically for the different for the speculation attacks across the whole kernel space. There are on map kernel when running in the user space configuration, and also a hardened branch predictor configuration. Also, it has some ARM-based, specifically on ARM 64 configurations. Also, there is one newly added configuration, which is the BPF unprivileged default off. The other category, the second category, is enabling the hooks across the kernel space, which includes enabling the hooks on the network space, on the dmessage, on the path, or enabling hardened user copy allocator and such. And the third category is actually choosing which a security model to be used and to be utilized for the specific attack interfaces. So we first state, and also when we want to choose the different configurations on the instance types, the most important thing is we probably want to consider how much the cloud provider wants to know how much performance jobs it actually brings. In this way, we could justify, okay, if it is too much performance burden and the safety attack, if we don't enable it, and the attack interfaces or safety issues brought by this configuration, by not enabling this configuration, might be not too significant in our use case. For example, if we are running only a key value store, and there is no unauthorized BPF or like or other functions running on the instance type we provide, does it like make any difference if we enable the unprivileged BPF, or if we don't enable the unprivileged eBPF? Like, what are the benefits if we disable it or enable it, and what are the safety and security concerns it brings in this case? So we'll probably go through them one by one, and like for both the security, safety related configurations and the security related configurations, and how they're like which part of the code did they actually change, and what are the like we are focusing on like what are the impacts for the runtime performance and boot time performance, and then from there we probably have some idea, general idea of whether it should be like suggested to be enabled on the host or guest. Elena, is that fine to get started in this way? Okay, Elena might like actually mute herself. So the first part, the first configuration we want to discuss today is about like it's like a former work of Shushan. The first configuration we want to discuss about today is like a memory management subsystem. It's on the heap memory, which is the configuration slap-free list randomization. This configuration actually is like a randomize. What it does is like it randomizes the kernel data structure, like so that each and every time it boot, it will boot into a new. There's a typo here. So each and every time when boots, the kernel data structure will be randomized at a certain offset, and it's hard to guess for like if you do the heap overflow and guess one of the kernel data structure locations, you could not get like in the next OS, it's hard for you to guess where it is. So we think that like the runtime performance impact is basically only adding a trampoline for translation for the kernel data structures locations, and even if we don't add this trampoline there, there is another like a map data to like translate where the location of the each and every kernel data structure locates. So like the difference between the runtime performance with this configuration on and off is not so significant in the runtime. It's only in the boot time that it might impact a little bit about boot time performance. Since what it does is like firstly generates a random number, and use this random number to change the locations. So we think it's like a boot could be acceptable, could be neglected, not too much.
Wenhui, is this a good time to ask a question?
Oh yeah.
Yeah, okay. You have the CVEs in the column here in column G. Kernel doesn't really publish any CVEs, as you know. So did you mean to say CWEs, or are they CVEs? Do you feel like you can gather enough number of CVEs from outside sources?
Yeah, we gathered. Yeah, you are right. We gathered actually some CVEs from the outside sources. For example, there's like a CVE database, and there's also a exploit DB. I'll put it down here.
I guess sure. The other thing is too that like the distros will log CVEs even if the kernel community doesn't.
Correct. So just making making a note that kernel itself doesn't publish CVEs. It has to come from outside sources. Thanks, Kate. Yes.
Okay, got it.
Distros do that.
Yeah, that's right. So like for example, for the ref.conf, if someone actually exploit the kernel when this configuration is not configured, like a long time ago when this patch was not added, like people generate like an old CVE number from there, and we just put it there. So is there any like some people like who doesn't agree with this idea, like for the performance impact on the both runtime and the boot time could be neglectable for this configuration for the kernel randomization? Okay, so if everyone agrees, then we move on to the next one. So the second one we would like to discuss here is like a config sub free list hardened. So what this operation did is like it added XOR operations on the slab free list pointer for addition protection. So in our idea is like our thinking is like it only as an XOR operation which consumes not too much in the runtime. So so this one will not add like the performance is neglectable impact because it's only XOR operations. And in the boot time, this configuration didn't do too much. So we consider as no performance impact on the boot time. So is there any issues with this conclusion, please? Oh, there's somebody in the chat.
There are a couple of questions in the chat. Looks like if you want to fill them now, then we.
Oh yeah. So we didn't evaluate like one by one for the performance impact. We are only like analysis of performance impact from a theoretical based on the code and our understanding. If we would like to like give the actual data, it might take quite a while to analyze the like 76 plus 20 something like configurations in total, and also the benchmarks like the actual performance downgrade about the performance is like especially in the runtime, like different configurations that they require like and have different impacts on the different benchmark. So that's a little hard to like explain. Okay, this configuration might have like a lot of performance impact on the file reading, and the other might have some other values according to the some other values. So like accessing the network per benchmark. So that's a little hard to give out the numbers for the runtime. But for the boot time, we could give some like only for the boot time we could only give some like numbers we collect, but that will be different from case to case. Like, and this number is like some of them are really small, so small enough that might be even smaller than the variance. Because you see like the XOR and randomization is like just getting the randomized data from the random number generator, the hardware, and then bring it to the trampoline from there. So might be smaller than the booting time variance. Yeah. So if it is significant and impacts a lot, for example, for some of the security configurations, like we have some evaluations. Yeah, but if it's not too much, then we'll just see analysis from a theoretical point of view. The third one is like to discuss is about like a configuration slap merge default.
Wenhui, a quick and easy test would be to see with and without these options, how long a kernel build could take. Is that something that, and then collect numbers, of course. So I was wondering that, have you used any simple mechanisms to see what impact?
Yeah, I collected the data for the security configurations, but not for the safety configurations. Yeah, for some of them. Let me show one moment.
How do you differentiate security and safety configurations?
Security configuration, the security refers to the information flow integrity, which means that on shared resources, we don't allow some of the like not authenticated people to access the security sensitive objects, which are the shared objects by other people. So that's called mostly called like the definition of security. And safety, some of them are related to like memory safety or like time safety, which means like it will bring the kernel to some errors we are not expected. That is the difference here.
So when you say information, it's the privileged information leak kind of thing situation?
Well, not rare. All of them are leaks. Let me bring one of the.
I'm using leak in a loose fashion. For example, if you were to have any addresses in the D message, that could be a leak as well.
Yeah, you're right. Leak is one of them. So both leak relates to the like confidentiality. So both integrity and confidentiality are important in terms of information flow. So so leak is like a read ability, and integrity relates to the write. So information flow includes both read and write, and also like executable and those configurations. Executable is like a read from its parent folder in the context of Linux. So it's read or write on the different entities, either on itself or from its parent folder point of view.
Thank you.
Shua, I think the question of safety relevance is one of the issues which I want to open up for discussion. What are the criteria, how we identify in this context what may be relevant for safety? So I think, you know, we have a beginning of an answer, but I would like to hear, you know, I mean, this is a working session, so if we can hear from people what their considerations may be, and maybe to come to some kind of more general understanding.
Yes.
If anybody wants to chip in from their experience or their understanding or their background, help here.
Sorry, I was compiling the document and takes a long time for like for the performance to be like data to be pull up. So these are the data like for the latencies, like a job for the different benchmarks on the different security configurations. For example, we could see that capability like calls for 4% off. I put it as taxation is like they are the regression numbers with this capability configuration on and off, and in some cases, some people probably could do the configuration for both SE Linux and AppArmor on the same system. So the cross number we didn't actually put it here, but mostly for some like evaluations for the current Linux system, we found like a regression is around for the module itself. The regression is like around, for most of the benchmarks, is around 5% to 24%. And for the current SE Linux, for the different benchmarks, it ranges from 9% to 78%, and differs from benchmark to benchmark. And also, we found that the latencies of the authorization actually end-to-end latency differs by what are the user space policies are. Some of the user space policies say if they are empty and it consumes so the end-to-end latency is small. But however, if the user space if the users put the security policies very complex, it might take a long time for the end-to-end latency. And also it differs on the some of the benchmarks they differs on the depths it actually uses for example, if you marketer or reader, you have to go through all the directories to get to access to the file. So there are previously in the someone might ask, there are a directory cache in the virtual file system. So why didn't it work? So like a directory cache system in the virtual file system only like records the previous like the D entry files like for quick accesses. However, it did not record the permissions. So we still have to go through the permission checks each and every time when we walk down the path. So that is probably something we have to consider to be added to the directory cache part to make it more effective. But that if we add the permission checks to the directory cache part, that might involve the another issue, which is like when do we do the revocations? That when could we do the invalidate of the permission checks? So that is another issue here. And this is a summarizing of the code and how many hooks are there on each and every kernel data structures, which we call like a security sensitive objects, because these data structures will be shared between the different processes. And when it is shared, we have when one data structure is shared between the different people, different processes, we have to check the permissions before they access in each other's each other's files. And also we did like a static analysis for like how many in the runtime, like how many permissions it will go through for each one of the hooks and such. Yeah, so that's just like for the previous question.
So I think understanding how this kind of maps to safety is the question here. I can see this kind of analysis would be really useful if you were looking at a Linux feature that you relied on for safety and you wanted to understand the performance impact. But also some of the analysis you've done is actually kind of focusing on tracing how, what kernel features are actually activated by on the path for particular operations. So there's some interest there as well. So there's not kind of an immediately obvious sort of this maps directly to safety, but there's a lot of commonality in the sort of analysis you're doing and the sort of requirements that you're looking for. So I guess maybe the useful thing to do is again focus on what the kernel feature is that you're interested in, because what effect that has on safety will depend on what your system is and what the safety function is and what it relies on. But then again the question is what's the value of the kind of analysis that we're describing? Is it about understanding if I control the behavior in this way in order to meet some safety goal, what's the performance impact? Or is it about how am I confident that that's actually going to operate? I can't yet see which of those this fits.
Yes, you're right. So we break down the configurations and each one of the safety and security features one by one, and hopefully after we generalizing the idea of each one of them, how they impact on the boot time and both on the boot time and the runtime. So we will have some idea when we combine these configurations together in a set in our instances, what will be the final result for the performance impact. We could be predicted from this configuration, so that when people are putting patches or people are releasing the images for the different instance types, we could give out some ahead notifications for the production team. Okay, like our consideration is like this new instance type might require these configurations as we suggested. However, for some of the benchmarks, like for some of the workload we would like to run on this instance type, they might be affected for the performance. We could give it a head, and then we could notice the production team, okay, for this for this type of benchmarks, we would like you to for the CI team, we would like you to especially do some tests to make sure it didn't get degraded, regression too much for the performance. So for we could point out the benchmarks to be specifically tested on, and do the optimizations from there, instead of run all the benchmarks and finding finding a needle in the hay, to see, okay, or maybe they tested a lot and didn't find any performance issues. We could give out some predictions from there while we are releasing the images.
When we, and maybe Paul, I'm to sort of reiterate and build on what you asked before. The performance here is very important, and I think Paul will have a lot to learn from it, and maybe we can apply it in other places. But I think we're still missing an earlier step here, and that's to understand, maybe we can focus on one of the specific configurations to understand the security considerations, and then from that together with participants here, to try to derive some safety considerations. Paul, does that make sense what I'm saying, or you want to try to add to that, or?
That makes sense, but yeah, I think maybe put it another way is that this is focused on security. Your benchmarking is about performance. How would you also incorporate something which is actually going to test whether it's achieving your security objectives? So do you have, for example, do you have tests that are trying to defeat the purpose of the security feature, or could you add some kind of a fault injection type scenario where you're saying, okay, I've got this kernel feature enabled which should prevent this kind of outcome that I'm trying to avoid. How, can I test for this instance type that it still works, that that it's actually an effective measure? I think that's how you would kind of make the bridge from measuring performance to measuring effectiveness. I think that might be the way to kind of make the jump to applying this to safety.
Yeah, that's really helpful suggestion. I think some of them, the configurations they have, if we put a CVE related to it, then we could search for the CVE ID, and there are some scripts to some of the scripts are verified by the exploitDB database, and we could find some scripts to exploit this configuration, exploit the system when the system is enabled without this configuration. However, it seems to be not all of the configurations, because some of them are had a long time ago, so not all of them we could find a CVE related. Probably have to if we want to came up with the attacks to the both the safety configurations and the security configurations on our own, it might take quite a while. Yeah.
But when I think my experience with this, I'll just clarify a bit more what Wenhui is saying here. In the security domain, the link between security features, such as these configurations, and CWEs and exploits is quite advanced. Okay, and if you look, if you search for that link, you can usually find, I mean, even, you know, available exploits which can do the type of testing which, you know, to exploit those issues and to do the type of testing, Paul, which you're talking about. Okay, I don't think we have such testing as prevalent in the safety domain. But for a lot of them, there should be at least security testing available. Okay, the types of fault injection which you're talking about to test the effect for safety is something which we need to define safety requirements and what we want to test here. It's a new ball game.
Yeah, absolutely. Maybe fault injection is the wrong term to use here because it kind of creates different connotations. But yeah, if you had the equivalent of an exploit for a safety risk, and tests to sort of show that your kernel feature, your kernel configuration feature prevents the risk that you're trying to avoid, a test to show that would be good. And again, the same applies to security. And I guess with security, if you've got exploits that you can run, that you can run as automated tests, then that's going to be great. You're not going to have that for all of them, perhaps. But yeah, if you're, again, it depends on why you're doing this measurement. If you're only interested in the performance impact, then that's that's fine. But I think it'd be really interesting to say, does the latest kernel version with this config enabled still actually achieve its purpose, still provide the security protection or the safety protection that I'm looking for?
But I think adding these two columns will be a good start, because I think it will help, first of all, to start bridging that gap here of understanding, because I think people will relate to the security exploits, even if they're specifically security exploits, but as a bridge to help understand how that, what we're protecting and how we define based on that. And probably should already add a column on the safety requirement. Well, I don't think on this table, but if we go to that is on the new features more to focus on that, then the CVEs for these features have already been defined. And now we want to try to, for the new features which you're defining, to define again, as we did in the past, to relate them to the CVEs. But here's an additional step of relating them also to exploits. And that maybe will help to give a better understanding of how some of these features are related.
One thing I have question is, do you have a list of, and there are a lot of configurations that have been evaluated here. Do we have a short list of 1 or 2 configurations that security only, safety only, and the ones that overlap security and safety?
These are the security only, alignment with the security part. And as you see here, the ones in color, they are the security only part. And for the ones in white are the overlaps between security and safety. It's on the 3rd tab of the Excel file.
So for example, config BPF unprivileged default one would be
They're considered
safety. It falls in both safety and security space.
Yeah.
Yeah, we did this analysis already in the past, but again, we need more, I don't know what to call it, more solid criteria and justifications here. So, and review.
Yeah, so that's hard to say, like, because some of the safety features, if they are not enabled, they, like, for example, if you override other people's memory, so that is considered as a violation of the information flow on the map data structure. So which is like security related as well. So whenever like you are reading or writing or executing something, like you are not authenticated and authorized to do so, like a one process is not authenticated and authorized to do so, that is considered as like a security violation. However, when it is this process trying to access its own like memory or the heap, however, like for safety concerns, it is violating the maybe it is his own. He could read and write this like a memory or like a memory. However, it is not supposed to read the memory at this function pointer stage. Maybe at a next when it calls another function, it's supposed to do it. It is like a safety violation. So like security and safety is like if it is restricting on the process itself within its own like access control domain, it is considered as a safety concern and the safety configurations. And if it is like across the different processes, it is considered as like a security.
Could you explain, so there is on the row 6, you have config slab merge default. So that is marked as no for safety. Safety default setting is no for that. Maybe I'm thinking if you were to explain one of these configs, why it is no for safety, and is this, would this be yes for security? That might be helpful for people to understand, maybe, at least for me. I be able to understand.
Sorry, I should explain it more clearly. So like the config BPF on private default off, so it's off. And
no, not that one. When we on row 6 in your document, it's config slab merge default.
One row 6, right?
Row 6.
This one.
Yes. Let me see. I'm looking at my screen. Yeah. Am I looking at the wrong one? I think the one document that you posted is the one I'm looking at. This one right here. Maybe that's not the one that you're showing right now.
You mean like the second tab?
Yeah. Yes. I guess. Yeah.
Sorry. Put it on. Now I see you.
Yes. Okay. Cool.
For the config slab merge default, it actually prevents the slab the caches of the slab from being merged by the kernel. This one actually is like mostly like the causes like the action item is only the kernel process, like the internal process providing it to be like merged, and it's not affecting other like user space, like different user spaces processes. So that's why we consider it as like a safety configuration for this one. So if like do you have like some concerns? Like from my personal point of view, I think it's like a safety configuration.
Definitely. That's yeah, I don't have any concerns about this being no for safety. I am trying to understand a little more clearly in the sense that it would be good to say what is the goal here? What safety goal does this achieve?
The safety goal is want to achieve is like to prohibit the the use of the free attacks. So like for some of the heap overflow exploits, it might be hard to like a previous day, if we don't configure this one, it might be hard to like override the objects in the same cache. So like well, with this one off, with not merged by default, so it make it hard to like overflow the heaps. Yeah.
Thank you. So that's good. So I was thinking that maybe if we picked a couple of these, such configs, I think Paul was suggesting that, and Elana was suggesting also, analyze those and see what kind of protections and what kind of checks could be made. See that the newer kernels still behave the way we want them to behave. This is good work. This is great. Thank you for doing this.
I think it's like, did I add it or should Elena add this line? Oh, remember.
Shua, just to clarify, this is the previous work that we had done, this tab. The new work is the third tab. This is old from before Wenhui's time, okay? And the new material is on the tab, the new security settings.
Yeah, tab 3, and also we added something
At the end.
At the end, yeah.
Okay.
Yeah.
Yeah, for the, I think the watchdogs was the old one as well, right?
Yeah, all of these are old. These
Uh,
are existing. It starts way down
I
somewhere
think
here.
these
You
ones
can see
are
this
new
is
ones.
new.
Yeah.
You can see there. Yeah.
Okay. Sounds good.
So
Okay.
like the new ones we added, first we want to confirm like this one are the safety configurations. I think the new ones we added are from here, right? From this one down, all the ones are new. So the first one is like config, like a page table isolation. So it enables like for us to like enables like two page tables at a time instead of one page table at a time. Sorry, there's a typo.
That sounds good. So we are about 4 minutes. How long is the session? It's a 1 hour session, Elana. We are about 4 minutes.
We have 2 hours, but what I would like to see here is a little bit of
like discussion,
sort of next steps here. So I think one suggestion that Paul made, which was a good one, was relating some of the more specifically security oriented settings to exploits. So I think that's a good suggestion. That's something to add. Relating to CWEs is something which we have done already, Shua. So I think we can expand that to the newer settings here.
Yeah, I think that one thing I am not seeing is CVEs are good, definitely. And we could also, if we could also add corresponding CWEs here, that might be helpful.
For the new ones, yeah.
For the new ones. And then also maybe identify, there are a couple of things I'm thinking about. I don't know what would be effective for us in terms of coming up with a safety goal. Is first of all, we have to make sure that the new kernel, the feature that we rely on is working the way we expect it to. That means no regressions. And then the second thing is, if that's regression testing we do is sufficient to evaluate our safety goal, is good. If not, we might have to identify additional ways to determine if our safety goal is still met.
Okay, I see one item here, like in column A for the new items, we do have to connect them more directly. The original items were connected directly to the definition of FFI. And I'll try to fix that up so that the new items are also related to FFI, because that already helps us to identify some kind of safety goal. Right?
Yeah. Shushan, do you mean like the Linux like a test suite needs to be added for the security regression tests as well to double check if the test suite actually covers these configurations with and without these configurations, and to go from there?
We might already have those, right? A particular feature might already have tests in various forms. It could be in kernel tests, KUnit and K-self-test, or an outside test suite like LTP. We might already have the test. So
I read some of the, like while doing the evaluation for performance, I read some of the Linux like a test suite that I did not find like maybe my understanding is wrong. I did not find like they are like specified for the testing for the security or safety configurations. Most of them like are testing on the functionality test, however, not on the like these configurations test.
right, there could be mix of that. We might have some tests, we might not have tests. If we do not, then that would be something that can be added. If we have them, do they meet our safety goals as well? Can they test for safety as well? If they don't, we'll have to add those.
Yeah, because like my personal understanding why Linux test suite didn't include this like test for the configurations is that the configurations could be added by the system like integrators on and off. So it is hard to put it up as like a unified test, because like different people wants to go across the different configuration set. And the Linux test suite right now is like testing the common functionalities, like no matter whether you have this configuration or not, like those functions will always be there. Like Linux test suite is targeted at those functions.
So
that's my personal understanding.
Depends on which one you're looking at. Some of the KUnit and K-self-test do depend on kernel configurations being enabled to run the tests. There is a way to specify which kernel configurations need to be enabled for that particular test to run. So there is some of that. You are right that some of the functionality that's tested it's more unit test focused, and some end-to-end. So for each of these, you kind of have to look at, for some of the configurations that you're looking at, probably there is no test available, but that's what we have to determine where the gaps are for each of the configurations we are interested in evaluating for safety goals and also regression goals.
Shua, where can we get that information from?
It's in the kernel repo.
Ah, okay.
For the
I'm checking that, so okay. That will be quite some project. Okay.
Yeah, okay. And also like who should we collaborate with if we found some like some of the tests to be added, and should we like start with a new little like a repo under the Linux like a test suite repo, saying like, okay, these ones are for each one of the configurations, what are the tests like structured in that way, or like how can we approach to this?
So I'll give you one example. It's in the kernel repo that tests for slab. Sorry, too much cut and paste there. But so who do you collaborate with when we? If you write tests, you can send them upstream, and people are very receptive to receiving tests.
Oh yeah, got it. Thank you. I read it. And going back to our topic today, like we want some like suggestions for these new configurations, whether they belong to, firstly, whether they belong to the safety configurations. And the other thing is like whether we should consider enabling them in our context, like to whether to consider we are based on whether enabling it is like based on the performance impacts. So we want to discuss it for today for this like several new configurations. The first one is like configure the page table isolation. Do you think this like this one will add some runtime both for the memory usage and the time usage as well. However, for the boot time, it didn't. The performance impact could be neglected. So, is there any like considerations for this one, or is it like a normal case for people to enable this, or like each and every time when you enable the pages, like we allocate 2 pages instead of 1 to avoid the overwriting of the page tables? Hello?
Are you looking for feedback on
yeah,
this particular?
Yeah. Sorry, yeah, on this particular, yeah.
Wenhui, you want to maybe a little bit of a technical background here, and that can help people who are not so familiar?
Oh yeah, so the page table isolation is to like each and every time when we do a page table allocation, we allocated the 2 pages table, two page tables at a time, instead of a 1 page table. So in that way, if we overflows, like it won't overflow to other people's page table. So that is like a page table isolation.
The question is, do we want to enable it or not, or do we want to, how do we test for it?
So according to suggestions, they support it is suggested to be enabled. However, it might like consume too much memory, double of the memory space, and also burn some like in a runtime, like allocating the 2 pages and allocating 1 pages that didn't take too much. According to reading the code, it didn't take too much of the differences. However, yeah, so but however, that's only like the memory usage is higher.
that's a given, right? Memory usage is going to be more when you do enable this. The question is, what is the benefit of consuming more memory? On a memory restrictive system, would you want to do this? I guess there are considerations outside of a clear-cut answer of yes, you should, or yes, you shouldn't, right? This is where probably it depends on your use case and the requirements.
Okay. Okay, the use case is like probably on different instance types. However, like I don't really know, like, because it's like seems to be already like already handled by the we don't have we don't consider the page table as a security sensitive object, because we don't think the page tables will be shared according to the mechanism of the however, safety configurations, they consider it as a safety concern for the page table isolations. So like, do you think it should be added as a default on or off? Like, is it like how much percentage, like how much possibility it for the user space processes if we're supporting VMs? Of course, if we're supporting the host VM, we'll have to enable this. However, if we would like to provide the container instances, for example, how I could not relate like how the different container instances could actually override each other's page tables, or like how could one container instance accidentally override its own page table?
I sent a link here, maybe you can open it up. It gives a little bit background here for people who are not familiar with page table isolation and why it's actually maybe very relevant to safety. Okay, so if you can open up the site to the here, relate. Okay. Okay, basically it's okay, there's this extra layer of protection between kernel space and user space, which is very effective and very relevant for safety.
So
okay.
Yeah.
And this is the kind of focus which I would like to see here to understand how these things can be hooked into safety. Okay.
Right.
And the performance issues and the integration issues are next step.
Absolutely. And to get back to Wenhui's question, whether it should be on or not, it needs to be looked at more closely in terms of what is the impact of having this kernel configuration option on the behavior of a runtime system. Like, for example, if you look at a file that implemented its entry.64.s, which gets run when our system call entry happens, and how it save and restore of a particular register behaves when this system, this configuration is on or off. So you have to, I think it's not a simple answer to say, should you have this on or not? There's a lot of implications on how this feature interacts with the runtime system and how the behavior, what kind of safety behaviors and security behaviors you are getting using by having this enabled. So that's why I hesitate to say you should have it or you should not have it as a without doing some analysis into code and saying what differences would you have if you did not have this option enabled.
Yeah, so it depends on like whether we are like vulnerable or whether the architecture is vulnerable. So I could probably put something here. What is this column? Whether the architecture is vulnerable to meltdown. Depends on. If it is vulnerable to meltdown, then it is like, and if it is like a meltdown alike attacks.
Well, so can you make that differentiation? Meltdown. I'm thinking this is you're talking about the meltdown, the actual meltdown.
Yeah, the actual meltdown.
Right. So that's another thing, right? We are finding that architectures we thought aren't susceptible to it. We are finding they could be, just depending on having the right way to exploit that vulnerability. So would you want to make that saying, well, today we know that this particular architecture isn't susceptible, and then would you want to do that? So it's a lot. I'm saying the answer is nuanced, not just saying yes, it can be no, because we want to save memory.
Yeah. So yes or no, like only applicable to the vulnerable architects. That's my. I think it's here.
Can you guarantee that architecture does not have that vulnerability, or what are the reasons why a particular architecture is not vulnerable?
Yeah, that is.
Can
like
you for sure say that it will never be vulnerable? So that's why I hesitate to say that you can just recommend a no without thinking through. I mean, saying yes is a safer option, right? Turning this on. But if you are making a call, whether you want to disable that to save memory on a system that might not have too much memory configured, then you have to understand what are the different implications and how the runtime system would behave, and do you have any safety considerations that would be impacted if you do not have this enabled.
Yeah, you're right. And also, yeah, you're right. And also the others, all the ones here from the branch type buffer and all the way to the side channel, these ones, they are all like related to meltdown and spectrum. So they could be analysis in the same way, if my understanding is correct.
Yeah, and I think that's a fundamental question of how we evaluate for a particular system relevance.
Yeah,
we need some
whether
background on what the criteria and why meltdown should be, for example, a concern for safety, and what type of systems.
Yeah, what type of like instances are vulnerable,
Right.
and what are the attack interfaces are there. So like these ones should be considered. Yeah, I'm writing it down.
Right. So we can make a note on that. We can add a column in the column on guidelines considerations.
Guidelines considerations.
We can add that some notes on that. I think that will help what Shua was talking about for the integrator to understand how we evaluate if it's relevant or not.
So which one should we add a column here, or what should we do?
I think there is one. Go a little further down to your right. There's general guidelines or runtime performance. boot performance, what else? Oops, no, not only
Yeah.
performance, what else? Oops, why did you go down?
Yeah, I'm trying to get to the ones to add it there. So this column, okay. Is my understanding correct? We should
that's
add
runtime performance, and what's in column M? Wait, I don't see if
it's a suggested for host or guest OS.
Okay, so
Maybe
I think
should put
maybe
it
we
as
can
like
extend the weakness and limitations or a little to more general guidelines. I think the column I is not only weaknesses and limitations, it's a more general column which describes, criteria and
yeah, I mean
okay.
like this is like a general guideline,
Yeah.
then put this line as like a runtime performance impact and performance impact.
Right.
Yeah.
Exactly. Mm-hmm.
Performance impact of so I will like change these lines like accordingly afterwards. Yeah.
Sorry, I was talking on mute. I said I'll work on the previous ones and you can work on the new ones. Sure.
Yeah.
When we okay.
Yeah, sure.
To make it more clear, and I think that will help.
Yeah. From the general guidelines, put it here as like for all the spectrums, consider analysis for attack interfaces, interfaces, and the possibility on the whether they are vulnerable. They are vulnerable to meltdown attacks. To decide what this so analysis for attack interfaces for this one, and the BTP store actually is like a branch store which is like a configure trampoline for it's still like for the spectrum variant 2. By adding a trampoline, we'll introduce like a stopping some of the attacks. This attack is more severe than the meltdown because it could leak the information of the sensitive data across the boundaries of the VMs. So we suggested as a default yes, because we found this like a spectrum variant 2 is subjective to the both architecture and Intel x86. However, there's currently no report for the attacks happens to be on AMD architecture. We don't know why yet, like why AMD, there's currently no report on the AMD exploits. maybe people are seeing like maybe it's just a small set of like cloud providers are using AMD. However, it seems to be this is not the case because when we do a summarizing of the cloud providers instances supports, it seems to be like there are a lot of AMD machines. Still have to diagnose, doing some diagnosis in like what are the difference between AMD and ARM and Intel that makes AMD so different. Yeah. So probably this one will be like a analysis for the not really on attack interfaces, because we know like it will go across the boundaries okay.
So did you look at the recent kernels, or what are you evaluating when you are saying that AMD is not susceptible and so on?
Yeah, the most recent, yeah.
5.18.
Yeah, for now really 5.18. I think we analysis on 5.10, 5.15, 5.4, 5.15, and 5.10. Yeah, those are
so the latest one you looked at is 5.17.
15.
15. Oh no, just go to 5.18. Take a look at this document. That's your golden standard. I put a link there. You can go to the repo and take a look. So this is what I'm cautioning against, making considerations saying that a particular vulnerability, some architectures aren't susceptible. I would say that we don't know yet. That's the approach I would take, as opposed to saying they are not vulnerable.
Okay.
So that's really how I would work, that no known vulnerabilities. This particular architecture is not known to have vulnerability right now, not susceptible right now, today, but doesn't mean it will change tomorrow, right?
Okay.
So
yeah.
this is your golden guide for Spectre anyway, and you'll find others as well. There is the hardware vulnerability documentation in the admin guide. I just put a link there. So I would really caution against going down the path saying, hey, this architecture isn't vulnerable, and sending system integrators down a path where it might become a problem down the road. So it's something that they have to continuously evaluate.
Yeah.
But Shua, I think we were talking about is I 100% agree. We shouldn't make any final conclusions, because in security, what is true today can change tomorrow as new attacks and exploits are revealed. But I think we were talking about more guidelines and criteria, and those should be valid, long term.
The ones definitely that are valid are good, but you have to really walk that line very carefully.
With caution.
Yes,
definitely.
Exactly. That's what I'm saying.
Definitely. Okay, and I think that was a good example to help us to to say where we draw the line. When we define guidelines, we won't make any statements. We don't make statements about or claims about safety in general, and we can't make those claims about security either. But we can provide some background guidelines, understanding, and that can help the integrator to make their own evaluation. And I think a lot of background information here can be helpful.
Yeah, so
why this yeah, okay, that's good.
So yeah, the conclusion is that this one is like based on instance types. This one is like proceed with caution, but highly suggest to enable it, because like no matter what the instance types, there will always be some issues. On map kernel at EL0. So like this one is like also like it's a violation of the security model of like at a different like a security model like the trust chain. It's a violation of the trust chain. So any suggestions for us, like for the consideration for the general guidelines for this configuration? Usually,
the one we're looking
yeah.
at is on map kernel.
Yeah,
at-
on that kernel E0, open it from.
I'm not familiar with this one. I'll have to take a look.
It's like trying to avoiding the, is it? Yeah. Speculation attacks against some high performance processors used to bypass the MMU permission checks and lead kernel data to user space. Actually, this one is like only 4% on ARM architecture.
Yeah, I see it's an ARM specific feature. Yeah.
Yeah. So when we come to, yeah.
Side channel type?
Yes, a channel.
Okay.
Yeah. I'll put it as like a supporting ARM only, considering ARM only actually. Like for this side channel, it happens a lot. So probably like suggested that always yes, because we in the cloud, in the data center, we don't have so many ARM motions, unless the ARM motions are like some of the cloud providers have our own designed ARM motions, and we could change the ARM instruction from there. So better consider this while we are like designing the own ARM CPUs. Is that?
So any of these configuration options that are put in place to mitigate vulnerabilities like such as these, I would always say yes, unless there is a good reason to say no.
Okay.
And do it at your own risk, right? So.
Okay. So probably yes here. Default, because this is the default suggestion.
For good reasons, at least we, from the ELISA perspective, I don't think we want to say it's okay to not have these enabled.
Okay, got it. Yeah. So this one was like a different. This one is like for the branch prediction buffer set channel attacks. It is like it is turning the by default. The Linux kernel is allowing the BPF, unprivileged BPF. However, like in the recent bug, that was like for the variant 2, spectral variant 2, like after like the paper actually exploits the kernel through the unprivileged BPF. So people added a new patch saying, okay, we should disable. By saying no, it's disabling the unprivileged BPF by default. So like my personal understanding is like on the instances where we are running the unprivileged unprivileged BPF, we disable it. We are configuring this as no. However, if we are actually providing the VMs, and if it is not a concern, and the BPF, there's no BPF running, or if we are supporting the function as a service or like a platform as a service, but without like a with no BPF code running there, we could just see but give it a yes for the performance concern.
So the answer would be, if that system is totally locked down and there is no way for anybody to add anything to that system, then the answer would be yes, right? If there is a possibility somebody could load and enable running BPF, then you would be at risk if you do not enable this option.
Yeah, that's my understanding. Based on
So for all of these vulnerabilities or configuration options and vulnerabilities, you have to look at the vector of attack. What is possible from the perspective of your own system, and then decide whether it is safe to turn, especially if you are disabling it.
yeah,
A protection, you want to make sure that you're doing it for the right reasons, and then you do not have a possibility of that your system is not susceptible to that vulnerability.
yeah.
So that is hard, right? It is something that you have to have a very intimate knowledge of that system and the runtime characteristics of that system and what is the exposure. So that's why I am very reluctant to make recommendations to disable these protections.
Okay, got it. So it's like a user default unless you have a specific reason to change the default setting.
Right. So I think that is for the system integrator to make a call on whether they want to disable a protection.
Got it. And the other thing is like I don't quite understand is like a live patch. So live patch is like a feature applies kernel patches without any system reboot. When I find a live patch, when I found it, like the Linux kernel, I think they suggested it as a no. However, like as far as I know, some system developers would like to make the live patch enabled. So I'm not quite understanding.
So I would say for live patch, it depends if you want to be able to enable live patching of the kernel. You have to be really careful with the sources of that live patching. I don't enable it on my systems. I want to be able to control when live patching happens. And there might be good reasons to do so, especially if you have a very controlled environment and you have lots of servers that you want to patch. It could come in handy. I do not know that it would be, no would be a safe option unless you have good reasons to enable it. It falls under the other category of say no unless you have good reasons to do so.
It seems to be like at least in our institution, like we found like live patch. We didn't enable it this year. However, like we are considering like using the live patch for the bug fixes. Like so, it could be applied for all the VMs without like rebooting and migration for the workloads.
Absolutely, there are good use cases for that. So this falls into the category of if your use case, you have a lot of benefit and then you control the flow of these patches, the source, you have a good control of your source, then where the live patching is are derived from, then definitely you there are benefits to enabling live patching. For example, the use case you talked about, you might have 100 VMs running and you want to be able to apply the patch to the 100 VMs without taking all of them down. So definitely the source of that, I haven't enabled it on my system. I don't fully understand, but it's something to look at how this feature works, and if you would like to enable it in your environment. And it is used, by the way, it's used for similar situations, hardware, VM, in all of these cases. It is, a lot of people use it for exactly the same reasons you're talking about.
Yeah, so like the conclusion right now for this one is like, how could I conclude it as?
So the conclusion would be safe to disable. Are we evaluating safety here or security here, and what are we evaluating this for your specific
safety
use case?
Yeah.
Okay, so I would say safety wise, this could be one of the things that you would say no, default, and evaluate a specific use case. Because I say this because we're also looking at knowing exactly what's running on our system and being able to say what are the modules and origin of those modules. That goes back to Kate's area of SBOMs. So we're saying that. So when live patching happens, do we have ability to update all of those or not? So do we know when after live patch happens, what kind of information we do have in terms of what has been updated on the system? So that is, I would say, for safety reasons, you would say no, unless we figure out that it is necessary for your use case, and then also being able to determine what is running on the system. If you can effectively tell at any point in time and say, hey, this is what has been patched, this is what hasn't been patched, and so on.
And Shua, adding to what you said, I would like to hear the details. Why the no for default? What is the concern? And what criteria would be relevant for actually enabling it?
The source,
and that
origin.
Will help somebody to make their specific decision, including links, perhaps, to if there's documentation somewhere or other work that has been done on this. And that's a general comment, which we cannot make black and white, binary decisions. Okay, things are very implementation specific, use case specific, but we can give criteria, and we can say why this is something that we may have concerns with safety if we enable. And I've heard here many comments, and I'm aware of other comments, but that has to be captured in writing here, okay? And other concerns which we may have, and why somebody, in any case, in spite of those concerns, may decide to enable it. Right. So those kinds of considerations should be captured, because that will be helpful information that somebody can read this and say, this is where I have to do my work, because and make the decision in my specific use case. But they have to have something to get started with, and this is the kind of information we should capture, and I think we'll be, and I know we're working with the other settings, which has proven to be very helpful for the readers. Okay, Wenhui, did you understand what I added on to what Shua said? To capture those details a little bit more, and even if we get started with that, we want to reach a stage where we publish this and that other people can add more information and more details, which will be helpful.
Yeah. So like, should I conclude as like, for the safety concern, no for this, for by default, and if enabled, we need a syslog for what are the new stuff to be introduced by the new patch, and also how could I conclude? Also, the system integrator should should have knowledge about what impact of the patch. Is my understanding correct?
I think what Elana was saying is when we say no, we have to say why we are saying no. And when we say yes, why we are saying yes. So we said safety concerns, right? For safety concerns, we want to elaborate those safety concerns and why we are saying no. What are the safety concerns? And that's kind of what Elana is saying. What this one concern I would have is the origin of the patch itself. If we are live patching, is that a secure source? So that would be my consideration. My concern would be for unless I can trust, is it a trusted source? If it's not a trusted source, definitely you would want to examine before applying these patches. If you are doing live patching, then you better trust your source. If you don't have an environment where you can trust the source, or you can, always that source is going to stay trusted, then you can enable it, but you have to determine that in your own environment.
Trusted source and have full knowledge. An
example would be, say you have your VMs, 10 or 100. They all go to a very secure, trusted source for their live patching, then you're good. You can ensure security and safety of that trusted source for your patching. If not, then if you're going to mirror one of the mirrors, then do you trust that? I mean, we do, right? When we do updates, I go to various our distro mirrors and we get it. But we know what it is. And when we are updating, we are consciously making a choice to update. So when you are doing live patching, then you have to make sure that the auto updates that happen are still a trusted source. Now, having said that, I don't fully understand live patching feature. So that's why I have to, before I can say what are all the consideration, I have to educate myself.
Okay, got it. Yeah, so like the several options. Suggested no for default. Like even if we know the patch is from trusted source, and we need to have full knowledge of the patch to enable the live patch. And even if we when we enable it, we have to do a syslog and what is introduced by the new patch and what are the impacts are there, and what type of code, which part of the code are like impacted by the new patch. Thank you so much. Yeah, for this guideline.
I think this is an excellent example, Wenhui, because it gives you here
yeah,
an
this is
example
really
of how
helpful. Yeah.
to do others as well, the type of guidance which you can look for. Okay.
Yeah.
And which I think this is already very helpful because it already adds some considerations. There's a lot of overhead here involved, and you have to make that consideration if it's worth it to invest in that overhead to enable this feature. So, you know, there's a trade-off here.
Yeah, I think it gives us a guideline. So when we talk with like a CI/CD people, like what to be enabled and what should take care of, and in the pipeline we could do a checklist. What yeah, it's very helpful for the
and not only in your use case, in general, for any reader, I think this is the type of guidelines that we're looking for. So I think this is an important point here. Okay.
Yeah.
And let's try to add these type of notes in other areas as well, because I think that will add a lot of value to the data here.
Yeah.
That we have. Here. Okay.
I will update the other guidelines from here. Yeah.
Okay. I think we're coming up to the top of the hour. I a little bit have to apologize. There's been a lot of going around on here in the background, so I've been less attentive than I would have liked, but I think some very good results have come out. Thank you, Shua, very much.
Thank you, Paul. Yes, Paul. Thank you, Shua. Thank you,
and
Paul.
to Paul, who dropped off already also. Okay. And others, even if you've been quiet, if you have access to the database or you can ask for access to the database, we'll be very happy to get feedback, comments, suggestions for improvement. A lot of this has grown because of, you know, people who have access, requested access and have given me insights. And this has been evolving very slowly, I must say. So we would like to bring this to a more ripe stage for publication. So any feedback will be helpful.
And also I was wondering, like for the alignment with security part for this page, what should we do with it? Could I like just say delete these ones? Because they are actually overlap with the previous one, just a delete, right? Six, and then leaving only the security descriptions on this page. Is my understanding correct? And also on the alignment with the security part, we probably add like a performance impact and the suggestions for the for some of the like make it similar to this one page. Is my understanding correct? Or we copy and put it on the second tab, or we just leave it on the third tab? Elena?
I would wait with those. Meanwhile, I think we have plenty of work on these, and I don't want to step over the bounds into those configurations which are almost purely security related and probably are not as relevant for safety. Okay, so I would leave that discussion maybe for a later stage. Okay. Even if at this stage first, even what a suggestion which came, I made some notes here and I'll share them with you as well. But you know, just even the whole issue of how we deal with Meltdown and Spectre related attacks, and how that is, and some guidelines to capture there, so that somebody who, you know, the reader can make their own judgment how relevant that is for safety. I think that already will be a big contribution, and maybe that will help us then to take the jump to the other ones. Okay, so
okay. Yeah, sure.
So I think we'll leave these for now. Okay, this has been, I hope, helpful for you and for me as well, I think, and I hope it'll bring us closer to publication.
Yeah, and also like for the categories, I added the categories like according to my understanding, probably we need to go through it again for these ones, like for the kernel configuration categories. Like for the later ones, I just added based on my understanding. I'm not quite sure if my understanding is correct or not.
I do have to drop now, so I think
Yeah.
we'll keep this here meanwhile, and we'll take this up at another time, okay?
Oh yeah,
We'll
sure.
go ahead with these, what we've discussed, and we'll continue, okay?
Yeah, sure. Thank you.
Okay.
Thank you very much.
Thank you, everybody.
Thank you.
Thank
Okay.
you. Good session.
Bye.
Okay, bye.
Bye.
Teléfono.